Yeah, so we have already completed demos, right? So 3 demos completed. So DevOps introduction, cloud introduction. So technical questions, general questions, which are very, very important, right? So before going to the subject, so we discussed about important questions and answers, technical questions, general questions, right? So today we are going to discuss about SDLC, Software Development Lifecycle, right? Yeah, today is the 4th session. So anyone newly joined today, first session, can you raise your hand, please? Anyone first session joined today? We'll provide you all the recordings. You can go through the recordings and you can continue from today onwards, right? Today is our 4th session. So 3 demos completed. So today is SDLC, Software Development Lifecycle. So before going to the AWS, Monday onwards, we're going to start AWS. Okay. So first we need to understand this SDLC, right? Yeah, let's get started. Yeah, it's a software development lifecycle, right? In multi-cloud DevSecOps, as a DevSecOps engineer, okay? So what is our role? What is our role, right? So developer develop the code, testers test the code. So infrastructure like operations team, they perform the operation activities, right? So what is our role? What we will do, right? Yeah, let's try to understand. Before going to that, let me show you something like Agile. So Agile and waterfall, right? We discussed already in the last session, right? What is Agile? What is waterfall? Agile is nothing but parallel development. Waterfall is nothing but sequential development, right? So 10 years back, 15 years back, we used to use waterfall. So in our project, previous project in Capgemini, so we used to use waterfall methodology 10 years back, not now, right? Yeah, so we used to handle the activities in a sequential manner. In waterfall methodology, development will not move forward because middle of the activity, middle of the development, any bugs happened, any hard fixes happened, right? Yeah, so development should be stopped, right? Developer develop the code. As a DevSecOps engineer, we work on automation activities, right? So middle of the activity, middle of the application development, any hard fixes happen, development should be stopped in waterfall methodology, right? So because sequentially the development will be happened. But whereas Agile is a parallel development. So front end, every application is having front end, back end, database, right? So 3 components, major components for any application, right? So that major components we can divide into sprints. Sprint. What is sprint, anyone? Sprint is a timeline, right? So sprint can be 1 week to 1 month. Sprint can be 1 week to 1 month. For example, so today one sprint started. By next week, Thursday EOD, that should be completed, which is a weekly sprint. Monthly sprint, for example, 29th May, so one sprint started today. By 28th June, EOD, that should be completed. So which is monthly sprint, right? In Agile methodology, we create the sprints, we work on the sprints, right? In Agile, so these are the stages we follow, right? Look at here, requirements, requirement gatherings, design, develop, test, deploy, review. Look at my screen. So these are the stages we follow in Agile methodology, right? First, we can planning, right? Requirement finalization, requirement gathering, right? So developers, they gather the requirement from client, right? After that, they start the application development. They work on coding, right? They work on coding. They start develop the application, right? So static code analysis, automated review, peer review, different reviews are available. So after that, the code should be built by using CI/CD tool. We can build the code, right? Yeah. After that, testing should be completed. Testers, they test the code. UI testing or penetration testing, requirement, whatever the testing, automation testing, Selenium testing, right? So testers test the code. After that, release. Once the testing is completed, so that should be the core application should be released. Released means, yeah, ready to deploy, right? So after that, we can deploy the application on respective application servers. Once we deploy the application, so after that, we can operate the application, right? So these are these 7 stages, so which are very, very important, right? So CI/CD stages, okay? So every application team, every project team, they are following the same stages, right? So in our codes also, this process we follow, right? But we don't need to worry about the coding part. We are not developers. We are not coders, right? We are not testers. So as a DevSecOps engineer, what we will do? We work on automation activities. We work on integrations. We work on deployments. We work on tickets, right? These are all the activities, fine? Yeah. Now, let me show you some examples here. Very important example. So for example, yeah, look at my screen, everyone. Yeah, let's try to understand. So here, SDLC. Yeah. So in development environment, so developer develop the code in their local workspace. Developer develop the code in their local workspace. What is workspace, anyone? Workspace is nothing but our local system, local laptop or desktop, right? In local laptop or desktop, we create one workspace. We means developers. Developer create the workspace. So developer A and developer B both are working on their local workspace, right? Local system. Once development is completed, what they will do? So yeah, local workspace, we can call it as, we can say, which is a Git local. Git local, right? In Git local, developer develop the code. Developer develop the code. They modify the code. They change the code. They push the code. They pull the code multiple times. They change the, yeah, coding, right? So once the development is completed, they need to push the code to a remote repository, which is, we can say, GitHub. So remote repository, we can say, which is GitHub. So this is a remote repository, or we can say GitHub. Basically, what is Git? First of all, what is Git? Yeah, what is Git? Anyone having idea? What is Git? And Git is a
repository.
Yeah. So Git is a repository tool. A repository tool or version control tool. It is a repository tool or version control tool. So what is repository? Where we store our data, where we store our source code is nothing but repository. It can be any data. It can be binary files, image files, audio files, video files, spreadsheets, WAR files, jar files. It can be any data. Where we store our data is nothing but repository. So what is version control? Version control is nothing but it track the changes over time. It track the changes over time, right? So for example, 3 developers are working on the application development. So 3 developers are working on 3 different components like front end, back end, database, right? So who is doing what? How can we track? By using version control system. By using version control system, we can track the changes. So this version control system allows you to add some comments here, like who did changes, when did changes, and what purpose did changes. So these comments will be allowed by this version control system. Who did changes? For example, Ram did changes. When did changes? By 8 p.m. IST on 29th May did some changes. What purpose did changes? Due to some prod issue. Prod issues did some changes, right? So based on these comments, Git will track the versioning, right? So multiple developers, they work on the multiple activities in real-time projects. Okay. Yeah. So who did what? How can we track? By using the version control system, right? So Git is a repository tool or version control tool. So Git local is the local repository. GitHub is the remote server. So once the development is completed in local, the code should be pushed to the remote repository. So currently our code is here. For example, developers completed the development in their local Git. So once the development is completed, they push the code to GitHub, remote repository, right? So this code should be deployed onto respective application servers, right? So this Git and GitHub completely developer tools. We don't need to worry about. Developers always work on the Git and GitHub. Once the development is completed, so next our role will be started here. Our role starts from here. Our next tool here is, in this flow, next tool here is Jenkins. So what is Jenkins? What Jenkins will do? Jenkins is a CI/CD tool. What is CI/CD? So continuous integration, continuous deployment or delivery, right? So continuous integration or continuous deployment or delivery tool, right? So Jenkins is the mediator tool. Jenkins is the mediator tool. It will integrate all the tools. It will communicate all the tools by installing plugins. What is plugin? Plugin is a package. It is a software. For example, this code I want to deploy onto respective application servers. So if I want to deploy this code on respective application servers, first of all, we need to pull the code from GitHub to Jenkins, right? So if you want to pull the code from GitHub to Jenkins, so very first thing we need to integrate GitHub with the Jenkins by installing plugin in Jenkins. So we need to install GitHub plugin in Jenkins. Once we install GitHub plugin in Jenkins, then Jenkins start communicating with the GitHub. So if you want to integrate GitHub with the Jenkins, we require one software, which is, we can say, plugin. Once we install the plugin, Jenkins start communicating with the GitHub. So after that, what we will do? We prepare jobs. We prepare jobs in Jenkins. So cron jobs we already know, right? In Linux, anyone having idea? Linux cron jobs. So like cron jobs, we can prepare the jobs in Jenkins. I'll show you practically while working on Jenkins. Okay. So we prepare the jobs in Jenkins and we can trigger the job in Jenkins. Once we trigger the job in Jenkins, this code will be pulled from GitHub to Jenkins. Right? So whatever the code we pull from GitHub to Jenkins, which is, we can say, raw code. Raw code. So raw code is nothing but unstructured code, unformatted code. So this raw code will not understand by application servers. So this code should be deployed onto respective application servers, right? So we have different application servers are available in the projects normally we are using. So here, this is application server, or we can say Tomcat server, app server, or we can say Tomcat server, right? So this code should be deployed onto respective application server. But this code is raw code. Raw code means unstructured code, unformatted code. So this raw code will not understand by application servers. That is why what we will do. We can integrate one more tool, which is Maven. So we can integrate one more tool, which is Maven. So what is Maven? What Maven will do? Anyone? Maven is a build tool, right? Maven is a build tool which generates artifacts. So artifact is nothing but archive file. Artifact is nothing but archive file, so which is binary file, right? So Maven take the raw code and it will generate as a single file. Artifact is nothing but archive file. So raw code is unstructured code, right? Different formats, different files. So that raw code we cannot directly deploy onto respective application servers. That is why we are integrating one more tool, which is Maven. How can we integrate? By installing plugin, right? So by installing plugin, if you want to integrate any tool with Jenkins, we require plugin here. Plugin we need to install in Jenkins, right? Once we integrate, so this raw code will be, Maven take the raw code from Jenkins. That raw code, it will convert into artifact as a archive file, as a single file. For example, look at my screen, everyone. So Java development is going on. Java development is going on, right? So when we talk about development, any development, not only Java, every development is having three types of developments, normal three types of developments. Desktop application development, and also second one here is web application development, and third one here is enterprise application development. So three types of developments: web application, desktop application, web application, enterprise application. So every organization, they're normally as per the requirement, actually, as per the requirement, but three types of application developments. Okay, fine. For example, this Java team, they're working on desktop application. So basically, what is desktop application, anyone? What is desktop application, anyone? Desktop application. Anyone having idea? Online guys, anyone having idea? What is desktop application? The application which we use in our local system, our local laptop or desktop, right? For example, paintbrush. Paintbrush is the desktop application. So, and also calculator. Calculator is the desktop application, or else media player is the desktop application. So these applications we can use in our local system, Notepad also, right? So my desktop application you cannot access. Your desktop application I cannot access. So which is nothing but our desktop application, local system, whatever the applications we are running on our local system, which is we can say desktop application. Got it right, everyone? And web application, second one, web application. What is web application, anyone? The application we host on server. That application we can access through internet, which is nothing but web application, right? So next one, enterprise level application, enterprise application. So millions of requests per second. So kind like cruise projects, digital applications, millions of requests per second, right? So the application gets millions of requests per second, which is we can say enterprise level applications, right? For example, Java team, they're developing desktop application. Here Maven, what it will do? Maven generates jar file, Java archive file. Maven generates jar file, which is a Java archive file. If the development team is working on, for example, Java development team, they're working on web application, right? Maven generates WAR file, web archive file. The Java team is working on enterprise level applications. Maven generates EAR file, enterprise archive file. So based on the application development, Maven generates the respective artifact. So Maven take the raw code from Jenkins and it will convert into, it will prepare the either jar or var or ER as per the requirement, right? Once the jar file or var file prepared here, for example, var file, Maven generated the var file. That var file will be pushed to the application server. Here we deploy the var file. So Jenkins take that var file and push to respective application server. Here we deploy the var file. Clear, right, everyone? Is it clear to you? So this is live application. In live, this process will be happening. Okay, live applications are nothing but like Flipkart, Amazon shopping site, Myntra, Meesho. These are all live applications. In live application, this process will be happening. For example, let us take Flipkart. Okay. In the Flipkart, look at my screen, everyone. Every moment, some changes will be happened here. So every moment changes will be happened, right? So these are all the microservices, for example. So these are all microservices, right? So this prices will be changed every moment. So some offers, right? So here offers, new products will be added here, right? Yeah. So discounts, weekend sales, year-end sales, right? Different sales are going on, right? Now, for example, look at my screen, everyone. So here, for example, yeah. So here 70% off, 60% off, 65% off, like this, right? So who will modify this code? Who will modify this application? Application team, they modify this changes, right? In local Git, they modify the changes. They push the code to GitHub. So from GitHub, Jenkins take the code and convert into artifact by using Maven, and it will push to the respective application server, respective Flipkart server. Here, the application will be deployed. So which is a live application deployment, right? So we have non-live applications also, right? For example, if you are using non-live applications, what will happen? So Maven generates the artifacts. That artifacts will be pushed to the respective Nexus repository. So this is Nexus repo. One more tool, Nexus repo. Here we store the artifacts. So whenever we have release, by the time we can push the artifacts to respective application server and we can deploy onto respective application server, right? So non-live applications, for example, we can say harshatrainings.com. So this is non-live application. So live applications are Flipkart, Myntra, Meesho, right? So 24/7. So any moment, application will be updated, right? So application team, they modify the changes, they push the changes. But here, non-live application, so we can down the website whenever required, and we can modify, right? So for which we required one more repository tool, which is the Nexus. Nexus is a repository tool to store our artifacts. So this Nexus is specially designed to store our artifacts. In this Nexus, we can store the WAR file, jar file, ER file. So whenever we have release, by the time this WAR files we can push to the respective application servers. Here we deploy the WAR file. Clear, right, everyone? Any questions, Andy, so far, anyone? Anyone having any questions so far?
Ram sir, what Maven and Nexus it will do? Like it will do the both thing, or it will be a different thing? Like, can you please explain now the difference of those?
Yes. Maven is a build tool. Maven is a build tool which generates artifacts. Maven take the raw code from Jenkins. It will convert into jar file or WAR file or ER file as a single file. For example, in your laptop, you have 200 documents available. I ask you to send those documents to me. So what is the simplest way to send those documents to me? How can you send?
I'll keep in the drive and I'll share you the link.
Okay. So instead of sharing all the files one by one, you can convert into one zip file.
Yeah, zip file. Yeah.
Right. And you can share through share folder or else you can attach to Gmail. You can send it across. Right. Same way, same functionality will work in Maven also. Maven take the raw code and convert into artifact as a single file that will give back to Jenkins. Jenkins push to the respective application server. Here we deploy the artifact. But whereas Nexus, so whatever the artifacts are generated by Maven, those we can store in Nexus here, right? Whenever we have release, so by the time we can push to the respective application server, we deploy the WAR files on respective application servers. So Nexus is a normal repository, right? Yeah, this Maven is the build tool. There is a huge difference here. Okay.
Yes,
Any other questions, anyone? Any other questions, anyone? Fine. Yeah, so we are talking about here application deployment, application development, application.
Sorry.
Yeah, go ahead, please. Yes.
Actually, GitHub is also a repository, and Nexus
Exactly.
is
Yes.
also a repository, right?
Yes, yes, yes. Very good
Why
question.
Nexus came into picture?
Exactly. Very good question. Yes. GitHub also repository, Nexus also repository. Exactly. Right? So we already having GitHub, right? Why we need to go with Nexus? Yes. There is a difference here. Fine. So very good question. So here Git is having some thumb rules. Git is having some thumb rules. What are those? Git will not accept Git will not accept binary files. Git will not accept binary files, and file size limit is 100 MB only. This is the thumb rule. Git thumb rule. Git will not accept binary files. WAR file is binary file, right? WAR file, jar file, ER file. These files are binary files, right? Git will not accept. That is the thumb rule. Git thumb rule. So before Git, we used to use one more repository, which is we can say Subversion or SVN. SVN or Subversion. So Subversion in our project also 7 years back, 8 years back, we used to use Subversion. Subversion will accept all the file formats. Subversion will accept all the file formats without any size limit. That is why Subversion is failed. That is why Subversion is failed. So because in our project, so 7 years, 8 years back, we used to use Subversion. So by the time, people used to upload their personal data also into SVN, Subversion. Subversion is one of the popular repository, but it is completely failed. We are not using currently. This is completely failed. We are not using currently, right? Subversion is failed because of, yeah, it will accept all the file formats and also without any size limit. So if you want to upload 1 GB, 2 GB, 10 GB, 20 GB data also, you can upload to SVN, Subversion. So in our project, people used to upload their personal data also into SVN. They used to upload movies also to Subversion server, SVN server. So that is why we used to get every alternate days, we used to get so many tickets. Subversion server is not accessible, performance issues, slowness issues, server down issues we used to get because Subversion SVN server accept all the file formats. So not only jar, var, ER, any file formats it will accept and without any size limit, right? So that is why we decommission Subversion and we integrate Git last 6 years, 7 years back, I think. So we integrate Git. So far we haven't seen any single issue with the Git. Git is running successfully, right? So here SVN is specially designed, sorry, Nexus is specially designed to store our artifacts, right? War file, jar file, ER files. But Git will not accept binary files. If you try to push the war file to Git, it will not accept because thumb rule, right? Look at here. Git will not accept binary files and file size limit is 100 MB only. That is why Git is successfully running. You understand, right, everyone? Is it clear to you?
Yeah, yeah. But Nexus will accept all the files.
Yeah, Nexus is specially designed to store our artifacts. Artifacts. War file, jar file, ER file. Nexus is specially designed to store our artifacts. Got it, right? I'll show you that. We have Nexus tool and GitHub, even SVN also I'll show you. SVN also we can integrate with the Jenkins. Fine. Yeah.
Yeah.
Now, so here developer develop the code, testers test the code. As a DevSecOps engineer, what we will do, what we are doing in real-time projects. We are deploying applications. We work on automations. We work on tickets. We work on code merging, code pulling, right? So here, where the testing will be happened, that is very, very important, right? So in Git level, testing will be happened. In local Git level, testing will be happened. GitHub level, testing will be happened. Even though once it is moved to Jenkins also, validation should be happened, right? But here, once the testing is completed, we have one more tool here, which is Sonar Code Review tool. What is Sonar? What Sonar will do? Sonar is a code quality tool or code review tool. So once testing is completed, once development is completed, so Sonar review the code. If any duplicate lines are there, any hot fixes are there, errors are there, it will find out. It will verify the code and it will provide the report. If any duplicate lines are there, it will provide you all the information. So that will be, once the report received by testers or developers, what they will do, they check and they remove the duplicate lines and again they push the code to GitHub, right? So every project team, every organization, they maintain the code quality, right? Code standards. So here Sonar is a very popular tool. So we have so many tools are available in the market, code review tool. But Sonar is a very popular tool. 70% of the project teams, they are using Sonar, right? So most popular tool. Fine. Yeah. So this Sonar also we can integrate with the Jenkins by installing plugin. So all the tools we can integrate with the Jenkins by installing plugin, right? Clear, right, everyone? Yeah. Fine. Along with these tools, we have other tools also, which are very, very core tools, very advanced tools like Docker. First tool here is Docker. So what is Docker? What Docker will do? Anyone? Anyone having idea? What is Docker? What Docker will do? Docker is a
Containerization.
yes container
Deployment tool.
tool, right? Container tool. What is container? What is container? Anyone? Container is it's a kind of box. Box. We can move anywhere. We can use anywhere. We can store anything on the container. So containers are advanced virtual servers. In AWS, we are using cloud servers, right? Which are virtual servers. In AWS, we are using cloud servers, which are, we can say, virtual servers, right? Virtual servers. So here, Docker containers are advanced virtual servers. Docker containers are advanced virtual servers, right? So these are a lightweight standalone executable program. So containers are lightweight standalone executable program, very faster. So currently we are using online shoppings, right? Most of the people we are using online shoppings, right? So even groceries, provisions, right? So Blinkit, Instamart, and Zepto, right? These are all digital applications. Okay, so when we book any items within 5-10 minutes, we are getting, right? Because of backend, they're using very advanced tools like Docker containers. So quickly that will be processed, lightweight, standalone. Even though Flipkart and Amazon shopping site, so when we book mobiles, even mobiles also they're delivering within 4 hours. They're delivering within 4 hours. So recently I booked one mobile. Within 4 hours they delivered. Within 4 hours they delivered. Right? So backend they're using very advanced tools like Docker containers, Kubernetes pods, right? So that will be processed immediately, right? Yeah. So Docker is a container tool, right? Container is a standard unit of software. Container is a technical term, standard unit of software. We can use anywhere. We can move anywhere, right? So it is not a platform dependent, right? So containers we can use in either Windows environment, Linux environment, Solaris environment, even Mac OS also. So anywhere you can run. Fine. Yeah. Our next tool here is advanced tool, which is Kubernetes. So what is Kubernetes? What Kubernetes will do? Anyone? Kubernetes is the container orchestration tool. Container orchestration tool, right? So what is orchestration? So orchestration is nothing but daemon, which will maintain the entire infra. Like infra means nodes, entire node servers, which will maintain. Right? It will handle all the target nodes, which is a container orchestration tool. So Kubernetes is advanced to Docker. Kubernetes is advanced to Docker. So Docker released in 2013. Immediately after 1 year, Kubernetes released in 2014. So both the tools are very popular tools, right? So currently every organization, they're using Docker Kubernetes. If you are good in Docker and Kubernetes, along with any cloud platform, right? So you can easily crack the interview. Okay. So Docker Kubernetes, every organization they're using. Okay. Yeah, these tools will go very deep dive. So Docker will take 8 days. Kubernetes also will take 8 to 9 days. Will go very deep dive. Okay. Practically, we can work on this Docker and Kubernetes, practical oriented sessions. So Monday onwards, we'll start. We will start AWS. So Monday onwards, so practical oriented sessions. So far, theoretical sessions, right? So these are the introductions and process, right? So Monday onwards, practically we can work on AWS services. First, we'll create the AWS account. Yeah, go ahead, please.
Sorry for interruption.
Yeah.
So I have one question. So Docker, we can say it's a server. It acts like a server.
Yes, Docker is not a server actually, right? It is a container tool. So Docker server is a server. So on top of that, we run the containers. So containers are not servers, which are, we can say, standard unit of software. So it is a lightweight, standalone, executable program, right? So containers are lightweight. Practically, we'll work on that.
And what is the use of then Docker, Docker? Is it
Yes.
like we can install software or something?
Yeah. So for example, currently we are deploying applications on. So for example, look at my screen, everyone. So this is application server, right? Here we deployed the WAR file. For example, Flipkart, we deployed here. In place of application server, we can use the Docker containers to run the applications, right? So here, we can integrate Docker also here. We can integrate Docker with the Jenkins. So in place of virtual servers, we are using Docker containers because containers are very faster, cost saving, time saving. But containers are not servers.
Okay. So this Docker is also provided by some other like AWS or GCP.
Docker is a tool, DevOps tool.
Okay.
Docker is a DevOps tool.
It has any memory or something or?
Yes. Actually, here what will happen? So Docker server is the cloud server. First of all, we need to understand something like Docker server is a cloud server. Okay. On top of that, what we will do? We run the containers. We configure the containers. Okay. So this containers will take the resource from Docker server. Understanding, right, everyone? So let me show you some example here. Okay, don't confuse. For example, look at my screen, everyone. So before going to Docker architecture, let me show you something like virtual server architecture. In a virtual server architecture, what we will do? We take one physical server. So this is, we can say, base OS, base operating system. So this server is a high-end server, like RAM we can use here, 48 GB RAM, high-end server. CPU we use 32 core, and storage we can use 10 TB, like this. Okay. So this is the physical server. Right? So on top of this, what we will do? We deploy virtual software. we deploy virtual software, which is, we can say, VMware or hypervisor, Hyper-V or Citrix. Once we deploy this software, what will happen? This software will allow you to create virtual servers. Understanding that, everyone? So before going to discuss about this Docker architecture, I just want to show you this virtual architecture first. Okay. So these are the virtual servers we can create on top of this physical servers by using the virtual software. So these are the virtual servers. Look at my screen, everyone. These are the virtual servers. Here we can deploy the different operating systems, different operating environments like RHCL, Windows, Linux, Amazon Linux, CentOS, whatever we require, right? But virtual servers are having some drawbacks. Virtual servers are having some drawbacks. So what are the drawbacks? For example, if you want to deploy operating system on a virtual server, we need to use the ISO image. So if you want to install Windows or Linux, so we use normally ISO image. ISO image is full blowing operating system. ISO full form is International Standardization Organization, right? So for example, in your laptop, if you want to install operating system, what we will do? Anyone? First, we need to copy the image into pen drive. That pen drive we can configure as a bootable drive. By using the pen drive, we can boot our laptop and we can install the operating system. That's the process we follow, right? Same way, server side also we use the ISO image. This ISO image size would be minimum 8 GB to 18 GB, right? Minimum 8 GB to 18 GB. Fine. Yeah. So on an average 10 GB. On an average 10 GB. 10 into we have 25 servers here. So 5 into 5, 25 servers, right? So 250 GB we need to spend for only operating system. On top of that, we need to deploy the applications, plugins, patches. That will take more space. This is one of the drawback. And also deployment time and downtime is high. So when you want to deploy any applications, takes some time. When you want to down, it takes some time, right? And also moreover, license cost is high. License cost is higher. So these are all drawbacks in virtual servers, virtual environments. Okay. So that is why every organization, every project team, they're migrating their applications to Docker architecture. So this is, Docker architecture. Let me show you quickly. In Docker architecture, Docker container architecture. In Docker container architecture, same as virtual environment, same as virtual servers, what we will do here? Yeah, we'll take one cloud server. For example, this is a AWS EC2 instance. This terminology is very, very important. Terminology is very important. So server, we can call it as EC2 instance in AWS. In Azure, we can call it as VM, Azure VM. In GCP, we can call it as VM instance. So this terminology is very, very important. Okay. We can take one AWS EC2 instance. On top of that, we can deploy software, which is, we can say, Docker image. This Docker image allows you to create Docker containers. Like this, we can run the containers. These containers are lightweight, standalone, executable program, right? So when we run the container, in these containers, only lib and bin files will be created. Lib and bin files, library binary files only. To deploy the war file or jar file, these files are enough, lightweight, right? So here, if you want to create operating environment, we use the Docker image here. So this Docker image size would be 200 MB only. So here 8 GB to 18 GB we are spending, but here 200 MB only. Why 200 MB? Why this much of drastic change? Because when we run the containers, only library binary files will be taken here, right? So not full-blown operating system. Understanding, right, everyone? Yeah. So here deployment time and downtime is very less. Deployment time and downtime is very less, right? So moreover, very less licensing cost. Right? So we need to no need to spend more budget for the licensing. So these are all advantages. So that is why every application team, every project team, they're migrating their applications to Docker containers because cost saving, time saving, very faster, quick response. So no downtime here, no downtime, not less downtime, no downtime, right? So we don't require any downtime. What is downtime, anyone? What is downtime, anyone? Downtime is nothing but maintenance time, right? In Docker environment, we don't require any downtime. Okay. So I think you understand, right? So what is container? What is server? Someone asked this question.
So in this architecture, we do not have an operating system, or a Docker image will act as a.
No. So this Docker image, once we deploy this Docker image on AWS server, this will allow you to create the container. Instead of the container, we can create the operating system.
Okay.
Okay. Yeah. Fine. Now, let's go back here.
Compared to VMware, what will be the advantage and disadvantage of containers? We can use this one on the production.
Yes.
Like how you have shown that the flow, like
Yes.
whenever there is a deployment, automatic deployment on Tomcat, example, the code is there, I want to deploy on the Tomcat.
Yeah.
Instead of on physical server, if I do the deployment on the Docker, how it will be like in production,
Yeah.
use this one?
Yeah, look at my screen here. So Docker image size. So this is the size, 200 MB. So here storage costing is very higher, right? So here very less storage we use.
Okay.
Deployment time, when you want to deploy any applications, quickly we can deploy. Quickly. So within a second, we can deploy. Downtime, less time. No downtime actually. So for example, when you want to restart server, it takes minimum 4 minutes to 8 minutes.
Right.
Production servers, right? So it will check the memory, updates, everything, right? So it will restart within 4 to 8 minutes. But whereas containers, within 15 seconds, we can restart the container.
Okay.
Very quickly.
Okay.
So these are all advantages. Downtime is less and costing is less, right? So client always look for the cost saving, time saving.
If something crashes happen on this container, means we can.
Yeah. So very good question. Here auto scaling is available. Auto scaling available in Docker. Automatically it will scale up. In case one container crash, automatically it will recreate one more container in place of the failure container.
Okay.
Auto scaling we can enable. That I'll show you practically while working on Docker and Kubernetes.
Thank you.
Fine. Any other questions, anyone? Yeah. Fine. So Docker and Kubernetes both are very core tools, very advanced tools, right? After that, one more tool we have, which is Ansible. Ansible we already discussed in the demo session, first session. Ansible is a configuration management tool.
Harsha, sorry to interrupt you.
Yeah.
I have one doubt because I was able to see that some of my friends they are using instead of Jenkins, they are using GitLab only, where there is an option of CI/CD pipeline from GitLab directly from the GitLab only.
GitHub Actions, actually. GitHub Actions.
GitHub Action. No,
Yeah.
GitLab also they have provided. I
Yeah,
have
GitLab is the repository. In place of Git, we can use the GitLab or Bitbucket.
no for in the private side. GitHub is a cloud based where we have to purchase the license, right?
Ah,
So GitLab is we can set up on our own environment on physical server.
right.
So in the GitLab also, I went through. There is an
Ah,
option. There only we can instead of Jenkins, they have means they have
CI/CD
it.
pipelines.
we can build that. Yes, yes. But
Okay,
here, Jenkins is very popular tool, very advanced tool.
okay, okay,
If you
okay,
understand Jenkins, you can easily understand other tools also.
okay, 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 okay. That's
Okay.
I was having
Yeah.
a question.
Yeah. Fine. Yeah. So here, Ansible is the configuration management tool. By using Ansible, we can automate the deployments. Any applications we can automate using Ansible. Okay. So after that, Terraform, one more tool. Terraform is a infrastructure automation tool. Right? So we can automate the infrastructure. So by using Terraform, yeah, we can create 100 servers within a minute by using Terraform. We can deploy, we can configure storages using Terraform, right? So Terraform is very advanced tool, very core tool. Currently, Terraform also every organization they're using for infrastructure automation. Okay. So along with this, Grafana, Prometheus, both are very important tools. Grafana and Prometheus. So both are monitoring tools. In AWS, we have CloudWatch and CloudTrail. In DevOps, we have Grafana, Prometheus. Both are monitoring tools. We can use these tools for monitoring our DevOps tools. Okay. And along with this, we have Argo CD, GitOps, different tools are there. And along with this AI tools, security tools, right? I'll provide you course content. Okay, you can go through the course content. So every tool will go very deep dive, not only installation configuration, not only theoretical part, right? Monday onwards, every session would be practically, every session will be a practical oriented session, right? So Monday we'll start AWS. First we create the AWS account. How can we create AWS account? How can we connect AWS account? How can we go through the resources, console overview, right? After that, we'll start working on the resources. How can we create the resources as per the project team requirement? How can we get the tickets? How can we check the requirement? How can we work on the tickets? So practically, I'll show you all the concepts, right? Yeah, so today is fourth session. So demos and introductions completed. So if you are interested, you can register today or tomorrow. So Monday onwards, meeting link will be completely changed. Okay, you can reach out to our admins or else you can call me, WhatsApp me. So my number also I shared right already. So this is my personal number. Take down these two numbers, institute number and my number. So you can call me, WhatsApp me if you have any questions. We'll discuss about it. Okay, let's discuss about the questions if you have any questions. And I provide you course content. So once you register, you will get the drive access, and also we will add into one community group so that you will get all the updates. Fine. So Monday onwards, link will be completely changed. Right? Any other questions, anyone?
Sir, one doubt. Like
Yeah.
for Azure DevOps tool is also same like Jenkins, right?
Same. Yes.
Yeah.
DevOps is DevOps everywhere. Right? See, even Azure DevOps also same. If you understand this, you can handle any DevOps, any process. Azure DevOps or GCP DevOps, any DevOps. So we are going to, in our course, we have three platforms will be covered, right? Three cloud platforms will be covered: AWS, Azure, GCP. Multi-cloud, right? So yeah, you can learn these three platforms. You can handle any DevOps. But this is the important one, right?
Thank you, sir.
Fine. Yeah. So if you're interested, you can register today or tomorrow. You can reach out to our admins, or else you can call me. So I'll provide you the full details. Okay. So Monday onwards, link will be changed. Fine. Yeah. So we can stop here. If you have any more questions, you can reach out to me. You can call me, WhatsApp me.
Sir, one doubt. Is there any scripting languages required, sir? Kind of Python or something to learn DevOps or something?
Shell scripting will be covered. Shell scripting.
Okay.
I'll show you the difference between Shell and Python.
Yeah.
Okay. Yeah.
I have another doubt. What is this Docker desktop tool does?
Yes. Docker web we can use or desktop also we can use. Desktop means in our local system, we can configure. Web is we can connect through internet. Okay. Both I'll show you.
Okay.
Right. Fine. Yeah, we can stop here. Any other questions, anyone?
Sir, is there any laptop for specific configurations required for this course?
Yeah, laptop or desktop we can use with 8 GB RAM would be better. So even 4 GB RAM also fine. So you can use any any processor, i3, i5 or any processor. Storage also 500 GB is enough to you. But RAM would be 500. You can use yeah, at least 8 GB. 8 GB minimum RAM size. So because while working on Kubernetes or Docker or Ansible, we'll get some performance issues. That is why better you can use 8 GB RAM. Storage 500 GB is fine, and a processor, any processor is fine. Even AMD processor or anything. Okay.
Yeah, thank you.
Fine. Yeah, we can stop here. Yeah. So Monday, so classes would be Monday to Friday. So tomorrow no class. Okay, because initially 2-3 weeks we will not have any weekend sessions. So after a few weeks we'll start working on weekends also. Okay. Fine. Yeah. Thank you all.